Hello and welcome to this video. This is the third video on complex number theories, and there will be one more video after this and we'll be done with complex number theory and ready to solve the problems. So in this one we need to find cube root, nth root of unity, not cube root. We need to find nth root of unity. So we have 1 is equal to cos 0 plus I sin 0, because sin 0 is 0, so imaginary part will become 0 and cos 0 will be 1, so 1 is equal to cos 0 plus I sin 0. Now to find nth root of unity, we have raised power 1 by n to 1. That means we will raise the same power to right hand side also. Now this cos 0 plus I sin 0 to the power 1 by n is equal to cos 2k pi by n plus I sin 2k pi by n, where k is equal to 0, 1, 2, 3 up to n minus 1. Now how we have written this, the reason why I'm trying to explain this is because new students who have not studied trigonometry will find it hard to understand. So suppose you have x, y coordinate here, and then cos 0 is 1 and sin 0 is 0. So if you rotate this with angle 2 pi, it will again lie in the same. So cos 2 pi will be also 1 and sin 2 pi will be 0. You rotate the full circle again, it will become 4 pi. So cos 4 pi will be 1 and sin 4 pi will be 0. So similarly, you can go on increasing the value of k to 3, it will become 6 pi and so on. And n has come from the power, so it is 2k pi by n. Now from Euler's formula, we write this is equal to e to the power I 2k pi by n. Now if we substitute k is equal to 0, 1, 2, 3 and so on, we will have 1 e to the power I 2 pi by n, e to the power I 4 pi by n and so on. We can write this as 1 alpha square up to alpha to the power n minus 1, where alpha will be e to the power I 2k pi by n. So these are the roots of nth root of unity. So because alpha is one of the roots, we can substitute it in this equation and we will find that 1 plus alpha square up to alpha n to the power n minus 1 is equal to 0. And product of roots will be equal to alpha to the power n into n minus 1 by 2 is equal to 1. The next topic is De Moivre's theorem. I don't know how exactly to pronounce this. So this is a very important theorem and it will come quite handy in many of the problems. So what this theorem says that if n is any integer, then cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta. So one of the simplest proof is by Euler's formula. We know that cos theta plus I sin theta is equal to e to the power I theta. We raise both sides to the power n. So we get the right hand side as e to the power I n theta, which will be equal to cos n theta plus I sin n theta. Now, the second proof we can do by induction. So for induction, we say that for n is equal to 1, we have cos theta plus I sin theta to the power 1 is equal to cos theta plus I sin theta. So it is true for 1. Now we assume that it is true for n is equal to m, that is cos theta plus I sin theta to the power m is equal to cos m theta plus I sin m theta. Now for n is equal to m plus 1, left hand side will become cos theta plus I sin theta to the power m plus 1, and right hand side we substitute this value over here and then we multiply with cos theta plus I sin theta, because right hand side should also have power m plus 1. Now if you multiply these two, you get cos m theta cos theta minus sin m theta sin theta plus I sin m theta cos theta plus cos m theta sin theta. Now you need the knowledge of trigonometry here a little bit, because this expression is equal to cos m plus 1 theta and this expression is equal to I sin m plus 1 theta. If you have not studied trigonometry of class 12 yet, you can just assume that this is equal to this. And later on, when you go through coordinate trigonometry, you will see that how this formula comes out to be. So we see that for n is equal to m plus 1, we have the formula as true provided it is true for n is equal to m. So by induction, we have proven this. Now for fractional and negative powers, you can prove it yourself. It is left as an exercise. Negative powers is very easy, because suppose it is -1, then it becomes 1 by cos theta plus I sin theta. Now we rationalize that. So on top you will have cos theta minus I sin theta by cos square theta plus sin square theta. So denominator will be 1. So the result will be cos theta minus I sin theta, which is equal to e to the power minus I theta. And similarly, you can assume for n is equal to minus m it is true. So this will become minus over here for power minus m. And then for m plus 1, this will get multiplied with cos theta minus I sin theta. It will get multiplied with the same. There will be a minus sign over here. So because minus sign will be here, this will become plus, and this will become minus. So it will lead to the same result. Now we are going to go through some geometric formulas of complex numbers. Much of this will not make sense to you if you are just into 11th, but bear with me. As we will solve problems, it will become clear that how it works out to be. So one of the formulas is section formula, which is straight up taken from coordinate geometry. So suppose we have 2 points z1 and z2 equal to x1 plus iy1 and x2 plus iy2. Then if z is equal to x plus iy divides these two in the ratio m is to n, then we have z is equal to mz2 plus mz1 by m plus 1, and x and y coordinate are given similarly. Now if z is midpoint, that is m is 1 and n is 1, then it will be 1 by 2 z1 plus z2. You substitute m is equal to 1, n is equal to 1, you get z is equal to 1 by 2 z1 plus z2. So this is the midpoint. Distance formula we kind of have already proven. So distance between z1 and z2 is modulus z1 minus z2. Now equation of line passing through 2 points is given by this determinant being equal to 0. The determinant is z bar 1, z1 bar 1, z2, this should be z2 bar 1 is equal to 0. Now if you evaluate this determinant, you will get z minus z1 divided by z bar minus z1 bar is equal to z1 minus z2 divided by z1 bar minus z2 bar. So how this equation has come, you will have to go through coordinate geometry to understand this. For now, you will have to memorize these results. Not really memorize, you write them in notes and refer them while solving the problem. The way to remember the formulas in mathematics is that you solve so many problems that you end up memorizing them by default. Don't force the memorization process. Collinear points also comes from coordinate geometry. It is the same. In this case, z1, z2, z3 will be collinear if the same determinant is 0. The only difference is the z is replaced by z3 here. So you see that this equation says that equation between 2 points z1 and z2 is given by the determinant. Here z is the variable. Now if you make z a fixed point, that is z3, then the same determinant has to be 0. For parallelogram, we have 4 points z1, z2, z3, z4, and these will represent the vertices of a parallelogram if z1 plus z3 is equal to z2 plus z4. So we know that the diagonals of parallelogram bisect each other. That means this point will be midpoint of BD and AC both. That means from the midpoint formula we have just found, it will be equal to half z1 plus z3 is equal to half z2 plus z4. That is z1 plus z3 is equal to z2 plus z4. For rhombus, we will have the same condition, which is for parallelogram, plus mod of z4 minus z1 is equal to mod of z2 minus z1. So we know that sides of a rhombus are equal and diagonals bisect each other. So because diagonals bisect each other, we have this condition, and because 4 sides are equal, AB will be equal to AD. So from this we have mod of z4 minus z1 is equal to mod of z2 minus z1. When I say mod, it is basically I mean modulus. For square, we have the same conditions, plus there will be an extra condition, is that diagonals are equal for a square. So that will introduce the condition mod of Z3 minus Z1 is equal to mod of Z4 minus Z2. So diagonals bisect each other, AB is equal to AD, and diagonals equal. So there are three conditions for a square. And then we have a rectangle. So for rectangle, we will have midpoints, that is Z1 plus Z3 is equal to Z2 plus Z4. And diagonals are equal in length, that is Z3 minus Z1 is equal to Z4 minus Z2, that is modulus of those. Now we look at centroid of a triangle. Suppose there is a triangle ABC, we have Z1, Z2, Z3, then the centroid is given by the point of intersection of medians, which is given by Z is equal to Z1 plus Z2 plus Z3 by 3. Again, you will have to study a bit of geometry for this, which I hope you have studied in class 10th. So from that geometry, you can deduce this equation. In center of a triangle which is given by IZ of a triangle ABC, it is given by Z is equal to AZ1 plus BZ2 plus CZ3 by A plus B, where A, B, C are length of the sides. A is the length of side BC, B is length of side AC, and C is length of side AB. Circumcenter is hard to compute, but it's not hard to understand. Okay, so circumcenter is the point of intersection of perpendicular bisectors of the sides of a triangle. So it is given by this equation. It is a mouthful to read, so I won't read it. And this is equivalent to this equation. So if you solve the determinants, you will get this. If you are not studied determinants yet, please have patience. I have not yet taught determinants. So also when we were dealing with the equation of line, that is a determinant equation. So this can be also written as Z1 sin 2A plus Z2 sin 2B plus Z3 sin 2C by sin 2A plus sin 2B plus sin 2C. And now we have circumcenter. Circumcenter is even more involving than this is circumcenter, right? Oh, this is something else then. This is, we have studied in center, circumcenter. This is orthocenter. Sorry, this is not circumcenter. This is orthocenter. So orthocenter is point of intersection of heights of the side. So for example, if you have triangle ABC, let me try to explain. You have triangle ABC. You drop perpendicular from A to BC. You drop perpendicular BE from D on AC, and then CF on AB. These three perpendiculars you drop, then you will find that the point of intersection is orthocenter. Now this orthocenter is typically represented by H, which is given by this equation and these equations also. So you see that these are quite complicated equations, but still I won't ask you to memorize any of these equations. When we will solve problems, these will come in action, and then eventually you will end up remembering all the formulas. Now from geometry, we know that there is a Euler's line where centroid of the triangle divides the line segment joining orthocenter and circumcenter of the triangle. So it divides it in the ratio 2:1. So with this, we come to the end of this video. All I would ask is have patience, and in due course of time, all these equations will come clear. Next video will also introduce more formulas, and it will be hard to understand if you are just beginning class 11 course. But as you will solve problems and understand different subjects like coordinate geometry or trigonometry, it will become clear. So for example, you don't know what is the equation of a circle. Okay, the general equation of parabola or ellipse. So all these things come into when we are dealing with the complex numbers. So with this, I'll end this video, and I hope that you have found this video useful and informative. So please subscribe to the channel and like the video so that this video can reach many more students like you. If you have a question or you want to correct me on certain topics, then please leave me a comment, and let's see you in the next video. Enjoy.